Alright, so today we're learning section 1.1, describing patterns. We're in our textbook on page 5. Page 5 in our textbooks. Alright, so let's look at example 1. Before we read example 1, does anybody have maybe a definition of what a pattern is? What's a pattern?
Something that repeats itself.
Perfect. Something that repeats itself. So if it repeats itself, then I can predict what's going to happen next, right? That's what a pattern is. So let's look at example 1. It says you're a member of a summer movie club at your local movie theater. The club meets every Wednesday in July to watch a movie. If the first meeting is on July 6th, on what other dates in July will the club meet? All right, so we know that the first date is going to be July 6th. So we can just write that down. So under example 1 in your notes, you can just write July 6th. Now we need to figure out what the pattern is. So we call this the description of the pattern. Anybody see a potential pattern in figuring out the rest of the dates? Anybody see it?
Since it says every Wednesday, and it's July 6th, you add 7 onto the 6 every time.
Yeah, perfect, perfect. All right, so since there's how many days in a week, guys? 7 days in a week, I know that I'm going to add 7 to every one of these dates to figure out the next numbers in my pattern. All right, so the description of the pattern is going to be add 7 days. So if I'm adding 7 days, what's going to be the next date that the club would meet? What is it? Yeah, very good, 13th. What would be the next date? What would it be? 20th. Very good. What would be the next date? Very good. What would be the next date? 34th. Wait. Can you have a July 34th? No, you can't have July 34th. So logically speaking, the 27th is the last date in the pattern, right? Because there is no July 34th. All right, so these 4 dates would be the correct answer. Whoops. And you just want to box it in. Box in your answer. All right, questions on that? Anything? Okay, so in example 2, now we're just extending a numerical pattern. This is more like what it's going to look like on your quiz and your test. All right, so you don't have to write this beginning instructions right here. You don't have to write that in your notes, but I do want you to write the first 4 numbers in the pattern in your notes under example 2. All right, so we have 2, 7, 12, 17. I'm going to give you just a second to see if you can figure out what the pattern is here. All right, that is correct. We are going to add 5 to each number. So again, for the description, I need the operation, add 5. Okay, and now that I know the pattern, I can fill in the next 3 numbers. Class, what are going to be my next 3 numbers? 22, 27, 32. Okay, and if this was a homework assignment, you would box in the next 3 numbers as your answer. Oh, I'm sorry, I boxed in 4, but you would box in the next 3 numbers in the pattern as your answer. All right. Okay, in example 3, I'm still doing the same thing, except now I just have to figure out what the pattern is. It's going to be a different pattern. So I go 2, 6, 18, 54. All right, someone raise your hand and tell me, what's one way you can get from 2 to 6? What's one way you can get from 2 to 6? Yes? Okay, I can add, make sure you say the operation, I can add 4, right? Okay, well that works. 2 plus 6, or 2 plus 4 is 6. What's 6 plus 4? 10, wait, that's not 18. So that pattern doesn't work. Even though 2 plus 4 is 6, 6 plus 4 is not 18. So there has to be another way that you can get from 2 to 6. What's another way? Yes, Bruce. Very good. I need to multiply by 3. So 2 times 3 is 6. 6 times 3, is that 18? And then 18 times 3, yes, is going to give me 54. So my description, sometimes I have to test my pattern on more than one number in the series. Does that make sense? because there can be more than one way you can get to the second number, but there's only one consistent pattern. Multiply by 3. Okay, so 54 times 3 is going to be what? What is it? 162. Anybody do 162 times 3? In your calculators? All right, so we've got 486. And what's the third one? 1,458. All right, next three numbers. So sometimes they get big, and that's why we have calculators. All right, we can just use them to figure out the next three. All right, so guys, as far as numerical patterns go, that's pretty much everything you need to know. All right, now we are going to talk about visual patterns here for just a minute. If you look in your books on page 6 underneath example 4, page 6 underneath example 4, you're going to see a Hawaiian lei. Does everybody see it? Everybody see the Hawaiian lei? All right, so the Hawaiian lei has different flowers on it, and we're going to look at the pattern of the flowers to figure out what the next flowers in the pattern are going to be. All right, so we start off with, let me get there. Start off with, let's see, a yellow carnation, 2 orchids, red carnation, 2 orchids, yellow carnation. All right, so what do you think would come after the red carnation? What do you think? Y'all just tell me. What do you think? All right. It's going to be 2 orchids. You don't have to draw the flower. We'll just describe it. 2 orchids. And what's going to be the next one after the 2 orchids? Yellow carnation. All right, so we just described the next flowers in our visual pattern. All right, now, do you see your turn now underneath example 4, numbers 3 and 4? Do you guys see that? All right, now that's what it's going to look like on your homework, quiz, and test. Okay, so we're actually going to now do your turn now on page 6, your turn now, numbers 1 through 4. So you should see underneath your turn now, under example 3, numbers 1 and 2, and underneath example 4, numbers 3 and 4. We're going to take about 5 or 6 minutes to work through these, and then we'll go over the answers. All right, so on your homework, okay, now on your classwork, it's okay if you didn't exactly do it this way, but on your homework, make sure you write the original problem for these problems. It's going to be numbers 8 through 16. Make sure you write the original problem. So my original 4 numbers are 28, 24, 20, and 16. What is the description of this pattern? Just tell me. What are you doing? Not going down by 4, but you are subtracting. Make sure you use the term, the operation, okay? So we are subtracting by 4. All right, and then what are the next 3 numbers in the pattern? 12, 8, and 4. Very good. Okay, now you can write them as the next 3, or on your homework you can just fill them in after the original numbers in the series. Either way is fine. You don't have to do both, okay, but either way is acceptable. All right, number 2, what is my pattern? What is it? Dividing by 2. Now, it may be tough on some of these to figure out the connection between your first 2 numbers. Okay, whoa, 256 to 128, that's kind of big, but maybe you could start with the last 2, 64 to 32, see if you can figure out the pattern, and then go back to the first 2 numbers and see if the pattern fits. All right, so you can work them out of order if that could help you kind of establish that pattern. All right, so we are dividing by 2, so what are going to be the next 3 numbers in our pattern? Very good. 16, 8, and 4. Very good. All right, so that's the answers to 1 and 2. Did anybody get both of them right? 1 and 2? Both of them right? Now, we're not going to draw out 3 and 4, but I want you to describe to me what is the pattern. What is the pattern on number 3 that you see? What's the pattern? Yes? Okay. Very good. You're moving the shaded block clockwise, so the next 3 in the pattern would be bottom right, bottom left, and then top left. Very good. All right, what about number 4? we are doing what? We're adding a row of dots to the base. Okay, so in the next figure, I add one more row. I go from 1 to 2 to 3 to 4, and then my next 3 should be 5, 6, and 7. It's getting even bigger. All right, and if you understand that, that's everything you need to know for 1.1.